Hi everyone, this is the third chapter in the COVID-19 desktop widget development tutorial series. In the last chapter, we implemented up to the GUI, we designed the GUI and we linked the GUI to the main class. Currently in our project, when we start the application, it will look like this. There are still some modifications that we have to do with the GUI because first of all, we need to get rid of the top white section. We don't need that because it shouldn't have this minimize, maximize, all this white section. We need to get rid of that. Then we have to inflate this text with the actual data we fetch from the online API. So let us start working on it. First of all, in order to get rid of that decoration, we have this option. So set or we can provide init style and stage style dot undecorated. If we set the stage style to undecorated, then we will get this effect. But there is still one problem. We have this launcher icon present in the taskbar. So no matter what we do, that launcher icon will be there, but we cannot have it either. So we need to find a way to hide both the decoration as well as this icon. One way to get rid of that icon is to make use of utility style. If we make it as utility styled, then you can see that there is no icon in the taskbar, but there is decoration. We need to get rid of both the taskbar icon and the decoration. In order to do that, we have to do what we say, like some kind of hack. Like we need two stages. First of all, this is when we start our program, a stage will be created for us. So we have to set its style to utility because we don't need that one to have any taskbar icon. So first of all, let us handle the primary stage. So when we start a program, we will set it as a utility stage, and then what will we do is to set it opacity to 0. So set opacity to 0. Now if we do that, let me copy this section to the top and comment these lines. If we do that, the advantage is that the program will become some kind of ghost. For example, right now the program is running, but you can't see any indication that the program is running. There is no window, there is nothing. The only way you can see whether the app is running is maybe through the task manager. For example, if I go to IntelliJ, you can see that there is Zulu platform x64 architecture. So the program can be seen. I think one of this is our program. Let me end it. As you can see, it is ended. So it is running just like a daemon. So in the first section, we have it. We have the program running in the background, but there is no indication in the GUI side. Now the second thing that we have to do is to create another stage here, a secondary stage. So let me call it a secondary stage, and let me create that stage. So a secondary stage is created, and for this secondary stage I am going to set the going to set the style as undecorated. Then what I'm going to do is to initialize parent or owner as the primary stage. The advantage of setting this owner to primary stage and undecorated is that the new window will not have any taskbar icon, or it will not have any decoration. So by adding these two lines for the secondary stage, we can hide both the decoration and the menu icon. So we have those two things. Now the next thing we have to do is to create a route and create a scene, and then instead of setting this scene to primary stage, we can set that to the secondary stage, and then we can call secondary stage.show. If we do this, and let me show you, if you run this program, then this window doesn't have any decoration or any menu items. So that section is covered. Now the next thing that we need to provide is to make it start at the end of the screen. For example, when I start this program, it is starting at the right top corner of my screen. In order to do that, first we need to access the screen rectangle. Let me show you first. Let me add a comment, make it right top aligned. Okay, the first thing we can use is make use of a rectangle 2D from JavaFX geometry, visual bounds. I think it is not JavaFX geometry. Let me check. Visual bounds, screen dot, yeah, it is get primary, get visual bounds. What it will do is it will create an object with the bounds of my screen. Like there will be a minimum x, which is my left side, minimum y, and width and height of the screen. Now I have my screen's dimension in this object, visual bounds. So the next thing that I have to do is to set x and y coordinates for my program. So it is going to be secondary stage dot set x. So I need to set the x value. So what I want to set the x value is to this is the point that I am going to set. I hope you can see my mouse pointer, or let me make use of paint. So the idea is like to create the window like this, and regarding the point that this is the point that I want to, oh, how can I this is the point that we have to tell to align the stage. So this point is this much distance. Like let me, it is very hard to do it in paint. So this much distance plus width of my scene, right? So it is the distance of my right edge to the screen plus width of my screen, width of my scene. So set x, for set x I am going to set it as visual bounds dot get maximum x, which is the right end of the screen. Then I'm going to minus two values. The first one is 25, that is the padding, that is this white padding section or this much section. And then I am going to reduce the screen, my scene width. So scene dot get width. Okay, now the x is set. Similarly I have to do for y. So I'm going to set y in such a way that I need to get minimum y, because this top end here the y is 0 at the top. So get minimum y axis, then I simply have to add 25 to it, because y axis is positive when it comes to downward, because this is the y axis positive direction, and this is the x, and this is the x axis positive direction. So with these two values, when we run our code, it should auto align to the right top section. As you can see, it is working fine, it is on top of there. So that is supported. Now the next thing that we have to do is to add support for drag and drop, drag and move, sorry. Okay, now we need to add let me close the original COVID reference program, because our program is now almost getting in shape. So let me close paint, let me close task manager, and let me write it here. So now I need to support for drag and move. So when you consider the drag operation, it is drag equals mouse click plus drag. That is how we drag, right? We click once, then drag it. So in order to support the drag operation, we need two variables. We need to make sure where is the click is happening initially. So private double x offset, private double y offset. So I will keep some values here when the user clicks on the, because the drag happens after a mouse click. So by recording the click position and after drag, we can calculate the distance between this current position and the mouse clicked position and calculate how much we want to move it. So scene dot set on mouse pressed, we can do that. Then we can add a mouse event, and inside that mouse event, x offset equal to current stage position. So stage secondary stage dot get x, current x axis of my stage, sorry, it will be minus, then event dot get screen x. So we are calculating the x offset. Similarly, we have to calculate the y offset, which will be secondary stage dot get y minus event dot get screen y, not scene y, get screen y. Okay, now we have handled the mouse click case. Now we just have to handle the drag case, mouse drag case. For that, we can make use of scene dot set on mouse dragged. And when the mouse drag event happens, we can move the secondary stage by setting secondary stage dot set x and set y methods. So the x-axis is going to be get the current screen x coordinate of the event plus x offset. Similarly, for the y-axis, set y event dot get screen y plus y offset. So using these two event handle listeners, one for mouse click and one for mouse drag, we can implement drag for any stage we want. So as you can see here, it is dragging very nicely along with my mouse. So the drag and move functionality is also working. So we made it top aligned, and we also made it draggable. Now the next thing that we have to do is to inflate these values. Like we have to set value for these text that we have. For that, we can go to the widget controller and start working in here. So first of all, what we need is a scheduler that in the beginning of this chapter we said that we need to refresh the data in a periodic manner automatically. So let's see how we can do that. For periodic and scheduled execution, we have a thing called executor service. So I'm going to make an object of that. So executor service. Let us just create an object there. Then here initialize, this will be called automatically when the fxml is inflated and the controller is invoked. So let me here write a function init scheduler. Yes. Okay, now here I have to create an object for the executor service. So executor service is equal to executors. You can make use of the executors from the java.util.concurrent package to create a new scheduled executor. So here you have a new scheduled thread pool which can make use of multiple threads to execute a scheduled operation, but for our purpose we simply need only one thread. So executor service can be created using new single thread scheduled executor. Okay, so what this executor service should do is to schedule an operation. So I think I have to change it to scheduled executor service here. So scheduled executor service, then here we can submit operation. So here there is an option called a schedule. We can make use of this scheduler to schedule this load data to be executed after some time. So here I am going to give this load data, and here I can specify the delay. So if I give it 20 and time unit dot seconds, then what will happen is this load data will be executed once after 20 seconds of invoking this function. So that is not exactly what we need, right? We need to execute it periodically. So we can make use of this one, schedule at a fixed rate or schedule at a fixed delay. I'm going to go with the schedule at a fixed rate. So every 20 seconds it will be executed. And here I have to provide one more parameter, that is initial delay. So initially after how much seconds it should start. So initially I need the data immediately. So this is how it executes. When you start the program, this function will be executed immediately. That's why we have given 0. Then every 20 seconds it will be executed. So far so good, we have that one. Now we need to fetch the data. So for fetching data in chapter 1, we created the data provider service. So data provider service, so data provider service, new data provider service, and here from here data provider service dot get data, and here we can specify the country name. For now we haven't handled the user configuration section where user can provide the data for the country and the period. We will do that later in the next chapters. So here for now I am going to give a hard-coded value, country name as India, then I am getting the result to India. Now this variable COVID data model. Okay, now I have all the data I need in this variable. I simply have to apply the data to these text fields. So those text fields will be text global report and text country report. So first of all, I need to make data in a fashion like this: cases, two dots, then cases colon, then the data, then one pipe symbol, then recovered, like that. So for that I am going to make a function private get format private that will return a string get formatted data, and here I am going to give 3 values. One is total number of cases, then recovered cases, recovered, then finally total deaths. So these are the three values that we are going to display to the user. So that is the value the function has to take. Then string.format, here we can specify the data. First of all, we need cases, and here I am going to make a fixed length decimal. So what this means is it will right align let me run the actual program and show you. So COVID widget, this is the one I created first. So here you can see that regardless of the number, they are left aligned. So this minus symbol means align the number to the left. And if there are 8 numbers, display all numbers. If there isn't 8 numbers in the number, then simply display spaces there. So that is what means that that is what that means. So percentage minus 6d. Then I'm going to add one more pipe symbol, and that is going to be deaths. So deaths of percentage minus 6d. So that is our string format, and in the first percentage 8d we have to give total cases, and the second place we have to give recovered cases, and for the third case we have to give total deaths. So once we give that, the number will be formatted like this as we required, and it will be returned. So that is the formatted data that we need. Okay, now what we have to do is text country code. We have country report and global report. For global report, we have to set text. So get formatted data for that text view, and here we have to give the global value. So from the COVID data model, we have to get global data. So let me create an object, global data dot get cases, global data get recovered, global data get deaths. So what I'm doing is I am taking those three values, cases, recovered, deaths, that we fetch from the API, and formatting it and setting it to the text global report. So that text is the top one, the top row, and the second one is text country report. So in the country report, we have to get data from the country report. So COVID data model dot get country data. Let me press Alt Enter, introduce local variable. So here I have the country data. So country data dot get cases, country data dot get recovered, country data dot get deaths. So using these 4 lines, we are setting the value we fetched from the network to the GUI. Okay, I think so far it is good. So at first time at 0 seconds this will be executed, then after every 20 seconds this will be executed. There is one more problem here. The thread that we are going to execute here is not going to be JavaFX GUI thread, because this function is called from this schedule thing. So what we have to do is to make sure that this will be executed in JavaFX GUI thread, because we cannot do GUI operation from another thread. So in order to do that, I am going to move this to another function. So private void inflate data COVID data model. Here I am going to paste it to here. Okay, now let me show you the issue of not making it in the GUI thread. If I run this program right now, we make it some errors. So let me try that. Let me close all the widget that I currently have. Let me run the program. Okay, it is waiting for the data. Okay, so far so good, there is no problem, but let me check which thread is acting here. Sometimes it won't throw exception, but in most cases it will. Let me add a breakpoint here and run the program again. As you can see, the thread is not JavaFX GUI thread. The JavaFX application is other thread, but the thread that is making this change is some other thread. So that is not recommended for JavaFX. So we have to fix that. In order to run this function in main thread, we can use platform.runLater, and we have the runnable function, and we can simply put this code inside that. And if I run the program again and add a breakpoint here, you will see that it is running on JavaFX GUI thread rather than the separate thread that is used for the scheduled executor service. That is important. You should never do any JavaFX GUI operation on another thread, because sometimes that will lead to issues. So here you can see that it is on JavaFX application thread and everything will be fine. Okay, now we have our COVID widget running here. Now only thing that we are missing is, as I inflated the data, the width of the stage is not changed. The scene width has increased because the text is a little bit larger, but the stage is not able to contain the entire scene. So in order to fix that, we can do a simple hack. What we have to do is to write one more function, private void. We just have to readjust the stage, so it should take a window as a stage. Then what it should do is, first it should call stage.size2scene. What it will do is, it will adjust the stage size so that it will fit the scene. So set the width of height of this window to match the size of the content of the window scene. Now we have to call this readjust size every time the data is inflated. So from the inflate data function, I'm going to call the readjust stage, and there we need a stage. In order to get a stage, we can use any component. So here I am going to use text country code get scene get window, and that will provide me with the current stage, and size to scene. If I run this program right now, there is one more problem that you will see. So here you can see that the stage size is correct, but it is going beyond my screen. So I have to move the stage again to fit the to match with the change I made. So in order to do that, what I have to do is to copy this code. So I have to make use of this function here again. So what it will do basically is, it will get the bounds and adjust the stage X and Y so that it will stay 25 pixel away from the screen's edge. So in order to do that, we need again the scene. So I'm going to make use of that one here, and regarding the secondary stage, I can simply give stage. Now if I run this again, you can see that after the size readjustment, the window automatically moved to the left side, and the padding of 25 from both the right section and the top section is correct. So that's it, guys. That's the end of this chapter. We have successfully created our widget. We have made the widget look like an actual widget rather than a windowed application. And in the next chapter, we will see how to provide support for the JSON settings file. As you can see, what we are going to do next is to add the settings.json file and read the refresh time interval and country name and country code from that settings file. So see you on the next one. Bye bye.